Okay, so this is our fourth video in our series of the linear homogeneous second order ODEs with constant coefficients. Let's solve this one together and let's see what we get. So in this one, we have y double prime plus 36y equals to 0. You can see in this one, we were not given a y prime term. It's just straight up y double prime and then the 36y. And we're also giving two initial conditions because even though we don't have the middle term, we still need two initial conditions because it is a second order. So let's find the characteristic equation. So for this one, we're going to have then, as usual, lambda square plus, and because 36 doesn't have a y, so we can basically write it as 0 lambda plus 36 equals to 0. I'm just showing you because we don't have the lambdas, the y prime, the lambda term is just 0. So we can just have the y lambda squared plus 36 equals to 0. Now, we can solve this one multiple ways. Well, basically it's one way, just doing algebra. So let's solve it. So then we have over here that lambda squared is equals to negative 36. If we take the quadratic, the square roots to get the lambda roots, you can see we'll take the square root on both sides and also get the square root of negative 36. And every time we take a square root, do not forget that we always need to have that plus and minus, right? Every time you take a square root, you always need to write the plus minus. So from this one, we then get that a lambda is equal to plus or minus, and the square root of negative 36, it's nothing more than just 6i. And you can see that this is our roots. Once again, it's still two roots. It's not just one. We have a positive 6i and a negative 6i. But regardless, this is a case 3. Right? This is the example in case 3 that I mentioned you, that it's still complex, but because there's no real part, you can see the real part right here is 0. Then this is just, it takes the following form. So y of x, it's equal to, the exponential basically cancels, and we're just left with c1 cosine of omega x plus c2 sine omega x. So once again, let's identify. For this one, we get that beta is equal to 0, omega is equals to 6. Once again, it's just a number in front of the I. You need to put 6i or like 6 omega, or 6 omega x or whatever. This is just the following. So y of x, it's equals to c1 cosine of 6x, just 6x, plus c2 sine of 6x. Once again, nothing else. That's it. We're just focusing on the numbers. And this is the general solution for our for this specific problem. And once again, we are given an initial conditions, and in order to apply them, well, we need to also find the derivative of this. So let's find that right now. So the derivative for this problem, we have here then that y prime of x. Because this one, we don't have exponential, these derivatives are pretty straightforward. So this one will be negative 6 c1 sine of 6x, right? Because the derivative of cosine is negative sine, plus 6 c2 cosine of 6x. And we know the initial conditions. So we know that y of 0 equals 1. So we can apply that condition here. So y of 0 equals to 1. So we get 1 is equals to c1 times cosine of 0 plus c2 sine of 0. We know that sine of 0 is just 0, cosine of 0 it's 1. And once again, we're left with c1 equals to 1. And I hope that you guys have been noticing a pattern if you've been watching the previous videos. And then if we do then the y prime of 0 equals to 0, then we have 0 is equals to negative 6 c1 sine of 0 plus 6 c2 cosine of 0. And we know that sine of 0, it will just cancel out, it goes to 0, and then cosine of 0, it's 1. And even though we have here 0 equals to 6 c2, we know that c2 is just equals to 0. All right, so if that's the case, then we can already find our particular solution. And we get that y of x, it's equal to just cosine of 6x, because c2 it's 0, so this is just the answer to this problem. So this is our particular solution. So you can see how we went from the problem that we had. This one was a pure imaginary. And once again, we took the characteristic equation, we found the roots, we wrote the solution corresponding to whatever case we got, and then we took the derivative of that, we applied the initial conditions, and we got our particular solution. So this is the last step in this series. I hope that it's been helpful. You guys will have a lot more examples to practice later on, and we'll continue on the next video for the next topic. Thank you.